In this homework question, vandals are attempting to tip over Cabot Tower by pulling on a rope which is tied to the top of the building. So we have our building here, there's the ground, there's our vandal, there's the rope tied to the top. So that's the situation. The tower is 15 meters high. This distance is 15 meters. And vandals pull with a force of 3,700 newtons. That's the force in the rope, so it's the force due to tension. We can draw that one in there. So the tension in the rope pulls down on the top of the building, pulls down like this. Tension is the force, is 3,700 newtons, and it's applied at an angle of 60 degrees below the horizontal, so our 60 degrees goes right here. So there's our situation. We're asked, what is the torque applied to the tower by the vandal? Since torque is new, why don't we go through all three methods of solving it, and we'll see how they each give the same answer, how they all work out to be the same thing. So let's do method one first. So method one. Method one is that torque equals R times F times sine theta. So that's our method one. So the torque here, we'll ask what is the direction of the turning. So if the person pulls this way, the tower is going to fall down this way. So it's going to move clockwise. So our torque is going to be negative because the rotation of the tower will be clockwise because the tower is going to tip over, it's going to fall down. So it's minus R times the force, which we call T for tension, times sine theta. Here's where we have to be careful. Theta is the angle between the R vector and the force vector. So let's identify our pivot in this problem. So we'll put the pivot where the tower is going to rotate. It's going to tip over at the base. So there's our pivot. So then R vector is from the pivot to where the force is applied. There's R. When we're doing this method, we draw R and our force so that they're tail to tail. So we're going to take R, which is drawn right here, and shift it so it moves up here. So now here's R right here. So now R is drawn tail to tail with the force. The angle between R and the force vector is 60 degrees is here, 90 degrees is here. So that angle is going to be 60 plus 90. It's going to be 150 degrees. So our torque is minus, because it's clockwise. R is the distance from the pivot to the force, 15 meters, times the magnitude of our force, 3,700 newtons, times sine of the angle, and that's between R and force when they're drawn tail to tail. That angle, since R goes straight up when its tail is right here, R goes straight up, that's a horizontal, that angle is 90. T is 60 degrees below the horizontal, so the total angle is 60 plus 90, which is 150 degrees. Put this through the calculator and we'll get a torque of minus 27,750 newtons times meters. And the minus indicates the direction of rotation, which is clockwise. So there's method one. Let's do method two next. So method two says that torque is equal to R times F perpendicular, and of course we'll indicate the signs from the rotation. So why don't we just draw our tower again, because it's going to get a little crowded if we keep using the same diagram. So there's our vandal, there's our rope, there's our force, our pulling force. So that's our tension, which is 3,700 newtons. And here's from the base to the top is R, 15 meters. So our torque is going to be, the direction is going to be a clockwise rotation, so it's negative. The distance R is 15 meters. F perpendicular, we have to split our tension into components that are parallel and perpendicular to the tower. So there's the component that's perpendicular. Here's the component that's parallel. We know that the part that's parallel doesn't do any rotating, because if we push on something aligned with the pivot, it won't move. It's when we push perpendicular on the object that it will move. This angle is 60 degrees, so our T perpendicular is the component that's opposite 60 degrees. oh, oops. Our 60 degrees is an angle of 60 degrees below the horizontal, right there. There's our 60 degrees, same as in the top diagram. So our T perpendicular is adjacent to our 60 degrees, so T perpendicular is T times cosine 60. Cosine 60 because it's adjacent to the angle. So we get 15 meters times the magnitude of the tension, 3,700 newtons, times the cosine of 60 degrees. So we put that through the calculator and we get minus 27,750 newtons times meters. So if you're asking why did I use cosine here and sine here, the answer is because you have to look at the force that produces the torque. If you remember a trig identity, one of the ones that we know is that the cosine of an angle is equal to the sine of 90 degrees plus that angle. So the cosine of 60 turns out to be exactly the same as the sine of 150, and you can try that in your calculator if you want to test and make sure it's true. So you can use some trig identities to show that these are actually the same trig function. They give us the same thing. So that's methods 1 and 2 done. Now let's finish by using method 3. So method 3 uses the lever arm or the moment arm. So method 3 says that our torque is going to be found by the moment arm, R perpendicular, or the lever arm, times the applied force F. So let's just draw our tower again with our vandal down here, applying the force. He's on the ground. There's our tension force. And here's our R's from here to here, 15 meters. So for this part, our perpendicular is our moment arm. It's the distance from the pivot, and our pivot is right here, to our line of action of the force, and it has to be a perpendicular distance. So the first thing we do is we take our force and we extend that force. We make it long. So, and don't be afraid to use your whole page until you really get the swing of drawing these things. You can make them nice and long if it's going to help you. So I'm just going to draw our line. So there's our long line. This is called the line of action or the line of force. So now our perpendicular, our moment arm, connects the pivot with this line, and it has to connect at a right angle, which will give us the shortest distance. So to connect at a right angle, we could make a right angle with our ruler, just slide the ruler down till we hit the pivot. So now when we connect these two things, it's going to be at a right angle. So right there is 90 degrees. We want to be able to calculate this part. That's the R perpendicular, the moment arm. And it's also known as the lever arm. So let's think about how we find that with the diagram. The angle that is given is below the horizontal, that's 60 degrees. Here to here is 90 degrees, because this is vertical, this is horizontal. If this has to be 90 degrees, then this one has to be 30 degrees, because 60 plus 30 gives us 90. So let's think about how do we find our perpendicular. So this is our right angle. It makes this side the hypotenuse. This is our angle, so this side is next to our angle. It's the adjacent. This side is opposite our angle. So, yeah, because we're across from the 30 degrees. So our R perpendicular is opposite our 30 degrees. So our perpendicular is going to be R, the hypotenuse, times sine of 30 degrees. So it's going to be 15 meters times sine of 30 degrees. So that's how we go about finding those moment arms. So let's put that together in our torque equation. So the torque is equal to minus, because we have that clockwise rotation, minus R perpendicular, which is R times sine 30, times the force F, which is the tension. So the tension is the pulling force, which is 3,700 newtons. Put this in the calculator. Let's put the rest of our numbers in first. R is 15 meters times sine 30 times 3,700 newtons. Put that through the calculator and we get the same result, minus 27,750 newtons times meters. Again, we get the same result. So if you're wondering about that, we did sine 30 here and we did sine 150 right here, but we still get the same answer. That's another one of those trig functions. So another one of the trig functions that you might remember is that sine of theta is equal to sine of 180 minus theta. So that's another one of those functions, which gives us the same result. So there's your torque on the tower, done using the three methods. When you're going to work on this, you can of course use any of the three methods, since all will give you the same answer.